Hey there, Hampshire chemistry students. Welcome back. Glad to have you today. In today's video, we're going to be continuing talking about these Lewis dot diagrams where we're trying to model the sharing of electrons in covalent bonds, except this time we're talking about with ions, specifically our polyatomic ions. So let's take a look at an example here, something like sulfite. So in sulfite, we know that this has the formula of SO3 with a 2 minus charge. And like with our other setups here, we want to understand we have the correct number of valence electrons. So we've been doing this a bunch, right? Sulfur is in group 16 or 6A, so it's going to have 6 electrons. Same thing with each of the oxygens. So if we were just doing SO3 neutral, we would expect there to be 24 electrons placed around it. However, because we are dealing with an ion, this guy has a 2 minus charge. It has 2 more minuses than it would normally have. Hey, minuses. Electrons are minuses. So this minus 2 tells me that I need to make sure I'm adding 2 extra electrons to my overall charge. If this was a minus 3, I'd be adding 3. If it was a positive 2, I would be taking away those electrons because positives would mean I have more protons. But we're going to go ahead and add 2 electrons for our minus 2. So our total number of electrons are going to be 24 plus 2, 26 electrons that need to be represented in this diagram. So I've already got my arrows drawn here for my sulfur and my 3 oxygen molecules. And these are just the normal amounts of valence electrons. Each of them have 6. I still need to add these 2 somewhere. So where are they going to go? Well, they're going to go anywhere where things are, they're going to go anywhere that is wanting to attract electrons. Hey, attracting electrons, that sounds a lot like electronegativity. We should know that our oxygens are going to be more electronegative than our sulfur. So I'm going to go ahead and add 1 of my extra electrons onto this guy. I'm going to go ahead and add my second one onto this guy. Now I could pick any of the oxygens here because they are all going to be equally electronegative. They're all going to kind of try to fight over these guys. Okay? Now we probably wouldn't want to put them on 2, just kind of to be fair, right? Because as you add this electron, this one's like, yo, I need 2, you just got 1. Send 1 over my way. It'd be unfair if you got entirely full here. So let's take a look and see then how this is going to work out with our circling. Because we're now going to have a different setup than we normally would, right? We have pairs that don't need to be made anymore. Normally, when we talk about oxygen, we needed 2 circles. But you can see that this circling here makes it so all of the oxygens are happy. And my sulfur can just go ahead and go down and send this one to here. All right, pairing this guy with this pair here. Now, this oxygen didn't receive any extra electrons, so it's going to still need to kind of bust up this couple of electrons here so that it can get its full set. And really, that's about it. If you place your 2 electrons on 2 highly electronegative atoms, you can then set up your procedure. And we can just take this arrow diagram and turn it into our Lewis diagram, right? We had a single bond and a double bond. Right? Notice that our oxygens with the single bond have 1, 2, 3 sets of lone pairs, where our oxygen only has 2. And if we count up all of our electrons, 6, 6 plus 4, that gives me 16. And then 18, 20, 22, 24, 26 electrons. And we are good to go. So we've used all 26, we've made our Lewis dot diagram, and we're all good with our different types of ions. Right? So best of luck. Take a look at the other examples on your sheet, and we will talk soon. Bye-bye.